So this is joint work with Pierre-Olivier Gorinchas and Dimitri Vayanos. So the Greek depression is pretty striking. Between 2007 and 2014, Greek GDP went down by almost 1/3. So GDP per capita was around $35,000. So this is 2014 PPP, constant US dollars. And unemployment was around 8%. And in 2014, GDP per capita was $25,000, and unemployment was 26.5. So the basic question we're asking is what happened? Now, to answer that question, we have actually two parts in the paper. There is an empirical investigation, and then there is a model-based investigation. The basic question of the empirical investigation is, okay, was Greece really that bad? It depends, of course, what your benchmark is. So the whole point is to build a benchmark by looking at countries, mostly emerging markets, that have experienced sudden stops. And the answer is yes. It was that bad. It's actually much worse than any emerging market sudden stops we've seen, even if you restrict the sample to strict beggars who actually did not devalue. So we didn't know that. And we knew it was a bad crisis. We didn't know it was that bad. Also, the fact that it's worse than countries that kept a strict peg suggests that it's not just about the fact that Greece did not devalue its currency. And then we have a model to try to investigate what happened. And one story that we come up with is that the reason it was so bad is because Greece caught an emerging market crisis, an emerging market disease, if you want, but in an economy with leverage ratios of an advanced economy. So the metaphor we are using is a bit like catching measles. If you catch measles as a kid, you recover quickly. If you catch measles as a grown-up, it's pretty bad. So that's, we think, is partly what happened to Greece. So what we show is that if instead of, if you resimulate Greek history with the leverage ratio of your typical emerging market instead of Greece, you find a crisis which is more in line with what we see historically. So less leverage would have helped. And then I'll show you some counterfactual about banking union and fiscal discipline to show you to try to quantify how much better things would have been. So let's start with the empirical part. So we take a sample of countries that experienced financial crisis or sudden stops or sovereign default or a combination of this. Some are emerging markets, some are advanced economies, and then we compare Greece to these countries. So this is a comparison to every country that has a sudden stop. That includes emerging markets and advanced economies. And you have the 90% confidence interval. So this kind of study dates back to, I think for me it's the Calvo and then Mendoza, Korinek and Mendoza. So you condition at time t something bad is happening, which is there is a reversal of capital flows and GDP goes down. And then, so time t is the date of the sudden stop, the year of the sudden stop. And these are years. So for Greece, we date it to 2010. So this is 2010, 08, 09, 2010, and then this is 2014 for Greece. Okay. So the sudden stop episode typically that you find in the literature is sharp drop in output and relatively quick recovery. In Greece, instead, we see a very prolonged decline, so it's more backloaded. It's also much worse in magnitude. So that's, again, this is the real output per capita. You see around 30%, 30 or 0.3 log points. Now, of course, you might say, well, fine, but these guys here include people who had the flexibility of changing their currency or their exchange rate. So what happens if you compare Greece to countries that are sorted by their currency regime? So here you have, again, Greece, okay? And then you have 4 lines. So the green at the top, these are floating exchange rate countries. So surprisingly, you find the usual result that floaters do better in a sudden stop. The drop in output is somewhat smaller, and they recover faster. Then you have countries who tried to keep their pegs and failed. So these are the depeggers, and that's in orange. So they do worse than the floaters. And then you have the strict peggers who actually manage to keep their peg throughout. And these are in blue. Okay. Now, Greece is still much worse than these guys. For reference here, you also have the evolution of log GDP per capita for Italy, Ireland, Portugal, and Spain, which are the Eurozone countries. So pretty much every benchmark you're going to look at, Greece is going to be a lot worse. The question then is it really fair to compare Greece to these strict peggers? Well, not completely if you think that the reason they kept their pegs is because perhaps they knew the crisis wouldn't be so bad. So in fact, there is sample selection. The ones who really would have suffered a lot from keeping their peg, in fact, jumped from being blue to being orange. Okay? So then we have another comparison, which is we have two countries here that we're pretty sure they kept their pegs, not because they thought it was not painful. They kept their pegs because they wanted to get away from Russia, and they wanted to stay in the West. So that's pretty darn clear. And even compared to Latvia and Estonia, Greece is much worse. Now, not at the beginning, notice, okay? But Estonia, despite keeping their pegs, even though it was minus 20% GDP, right? They knew what they were doing. They knew the cost. They wanted to keep it because they wanted to anchor to the Eurozone. They recovered pretty much like what you would think from a sudden stop episode in an emerging market. They are 3 years later, they are not very different from your typical emerging market figure. Okay? And Greece is. Now you might think, okay, so Greece had a sudden stop, but also other things happened. They had a credit boom and bust, and then they had a sovereign default. Okay? So then you can compare Greece to countries that had the trifecta, which is sudden stop, sovereign default, and credit boom and bust. And there, it's kind of easier. You don't have to put standard errors because there aren't so many of them. So these are all of them. Okay? And you recognize the names, right? These are the case study that we teach. Mexico 82, Chile 83, Argentina 1. Greece is still worse than any of them 4 years later. Now, why is it so bad? There are many reasons, but one of them that's very important to keep in mind and explain some of what we try to do in the model is the thing that collapsed the most in Greece is actually investment. So if you now remember, Y output goes down a lot. So here I'm plotting I over Y. Okay. So the level of investment totally crashed also. But even as a ratio of GDP, that's telling you that C over Y didn't collapse as much. Okay. So the behavior of investment is quite striking. It collapsed to an extent that we don't really see anywhere else. Now, of course, this is, just to be clear, this is the sum of, this is investment NIPA style. That is, it includes housing. So we have another way where we look at housing, residential investment versus corporate investment. And housing crashed a bit more and a bit earlier, but the magnitudes are similar in corporate investment. So when you write a model about Greece, you kind of want to write a model with investment. And when you talk about, this is not a small shock, right? This is investment going down by 70%, so it's going to show up in K at some point. So it's going to, actually, it's not going to be like a small change in K. So we want to, and for the persistence, it's going to matter. So we're going to have that in the model. Good. OK, so then part 2 of the paper tries to make sense of Greece. I don't think I need to tell you that it's only partly successful, because given the mess and the complication, we tried to do our best, but we didn't succeed nearly as much as we hoped. But I guess it's just because we had unreasonable expectations, I suppose. OK, so some of the features are pretty obvious. You want a small open economy in a currency union. The currency union is going to set the interest rate, and there is some kind of foreign inflation there, or deflation. So that's what's going on in the currency union. And then that's a small open economy that trades with the rest of the union and has a fixed exchange rate. And it's going to be a standard New Keynesian DSG, so a bunch of shocks, and wages and prices are sticky, Calvo style. And maybe I'll come back to that, because I think given what we saw yesterday in the paper that we saw yesterday morning, it might matter actually the way you model nominal rigidities here. So this is the standard New Keynesian framework. And the big players are going to be the government, and then the banks, or whatever is the instrument for funding the private sector, which in Europe is mostly banks. The banks are going to fund households and firms. Households are going to have some debt B, and then that's going to affect their consumption. And then firms are going to also be subject to funding costs that depend on the banks, and invest and then accumulate capital. Okay, there's a bunch of shocks, so I don't want to. I don't want to bore you with all the notations, but every time you see a zeta, that's a shock. I call it a shock because it's kind of easier. The shock itself is an AR1, so the innovation is like this var epsilon, okay? And so all of these, and that's going to be like the usual Bayesian estimation. So you specify the stochastic process, and we're going to estimate the rhos and the sigmas. And this indicator there is going to be, well, they're going to have a bunch of shocks. Okay, so one is going to be a sudden stop, one is going to be a spending shock. Okay, so you show this zeta in the next slide, that's what they are. Each of them is like some kind of AR1, which is then estimated using a Bayesian method. Okay, so I don't want to, of course, I won't show you the whole model. I'm just going to show you the key features. So the government, okay, the government taxes. There is a flat tax on GDP, on total income. So that's for the revenues. And then the government does a transfer payments and G, spending. And then the way we model the government is like a spending rule. So it's like a Taylor rule, but except for fiscal policy. Okay, so the rule is saying the following. So first of all, there's some persistence that we estimate that fits better. And then that's the interesting part. So it has like 4 pieces. This piece here is just saying that if your debt is very high, you're going to cut spending. This is not important for dynamics. It's just otherwise you violate transversality conditions. So that's a small number that's just there for stability of the system. These are the important ones. So this is saying the government has some kind of countercyclical fiscal policy motive. So if N, employment, goes down, you're going to increase spending to try to counteract. Okay, so that's the countercyclical fiscal policy motive. And then the government is going to look at its funding cost. And if the funding cost is high, it's going to cut spending. Okay, so austerity induced by difficulty in funding the government is going to show up in this FR term. And then there's this autonomous spending shock. This is the thing we can't explain. So that's the part that the Greek government does that we don't really understand based on this simple rule. So that's based on a previous paper I had with Philippe Martin, where we estimate these rules for all of the countries in Europe. And they actually work pretty well. Like the residual for France, Germany, Portugal, these rules are kind of tiny, actually. These rules describe pretty well, except for one country where there is a big residual, and that's Greece. So this is going to play a role. Okay, so that's what the government does. Okay, and then, of course, it can default. So there's going to be credit risk on the government side. So this is the fiscal rule. Then there's a budget constraint, and then there's what happens because of default. Then the households. So these households are Campbell, Mankiw, Schiller kind of households. So there are 2 types. One is patient, one is inpatient. Like the same thing that was used later by Egerton and Krugman. So if you're impatient, you're going to borrow, and then you're going to hit your debt limit. Once you hit your debt limit, you're like a hand-to-mouth agent, but with one feature, which is interesting. You're a hand-to-mouth agent with some kind of endogenous to the model budget constraint, because your debt limit is going to be endogenous in the model. Okay, so you're a hand-to-mouth agent, but I can move around your budget constraint. And otherwise, you work, you earn labor income, you get taxed by the government, you borrow, you repay, you default. So DH is the default rate of household, and then you get the transfers. And then you have some banks. So we try to model the banks structurally, and we fail. So then the banks are going to end up being more reduced form. Some of the equations work, some don't. So the basic idea was banks have some kind of capital constraint, like Gertler-Carrady, really. And so they can lend. So this would be, for instance, the sum of their private lending to firms and to households. But they have a capital requirement, which says that their market value or book value, depending on which regulation you look at, has to satisfy this ratio. Okay, that's going to create some funding constraint for the banks. It's going to then translate into funding constraint for the private sector. Okay, but unfortunately, some of the more structural restriction of the model there, we just didn't have the data to estimate. Okay, so then there is a big part, which is you run through the equation, you figure out the solution or the approximate solution, and these are the key equations that are going to play a role in the simulations. First, the banks fund the private sector. So in log deviations, the cost of fund for the private sector, this is the RK. That's the RK that shows up in the Q equation. Depends on the funding cost of the bank. And in fact, in logs, they are the same. So it's like a constant spread. The banks borrow at 2, lends at 4. If it borrows at 8, it lends at 10. Okay. So in logs, it's equal. And then what happened to the funding cost of the bank? So the thing that kind of matter for the bank is their funding cost sudden stop style. That is how much they can borrow, what's the rate at which they can fund themselves, Typically, it's more like wholesale funding. But of course, in Europe, when the wholesale funding dried up, it was replaced by assistance from the central bank. So this is the sudden stop on the banks. And then if the banks make losses, so this is private default, the sum of household and corporate default, these losses are going to eat their capital. Because it eats their capital, they can lend less, and therefore the price at which they lend is going to go up. And so this is how private losses are going to feed into funding costs for the bank. So the funding cost for the bank is the baseline Eurozone, which doesn't move, essentially, plus a certain sub-spread, plus a private default induced spread. And this depends on the equilibrium leverage that the banks have, L. Then we model private default. This is reduced form, so that's a model where you have idiosyncratic shock and then some fraction of the population defaults. The government, is same story. The cost of fund for the government is R plus the part which comes from default risk. And the part that comes from default risk we model as a function which is increasing in, so there's a default shock, okay? And then you draw the default shock, and then if your leverage is above the default shock, you default. So then take expectation, take the logs, and you get something like that, which is the risk of default at time t plus 1 from time t's perspective. It's going to be increasing in your future debt to GDP ratio, and of course, deflation matters because it's nominal debt. All right. So then we do the simulations. So the thing I want to emphasize here is just that what we feed in the model is only things that we can observe, okay? And also does not include investment or GDP. So we don't feed GDP, we don't feed investment. The model doesn't know anything about that. We only feed the government revenue and spending, interest rate on the government, interest rate on, so that's RK, that's this guy here, funding cost for the private sector, the time series for non-performing loans, inflation, and the time series for household borrowing, okay? So then you can first check is, okay, what does it predict in terms of GDP and investment? So blue is what happens, and red is what the model predicts. So we don't predict everything, but I think in terms of, that's a model that doesn't have investment or output as an input. So that means that the sum of the demand shock that we put in the model and the way we introduce them seems to predict a path for output, which is reasonable. And investment, we predict a collapse. We just don't, we predict 55% instead of 70%. So we are still a bit short in terms of predicting the disaster. In terms of the net export, we get also roughly right. Inflation, well, there's a problem, which is here they changed the VAT, and so this spike we don't have in the model, which means we predict the deflation just 1 year earlier, which is a bit frustrating, but that's life. Okay, so then once you have the Bayesian estimation, you can reconstruct Greek history. So this is what the model spits out in terms of the shocks that it sees. So the way it interprets the boom is it sees this red stuff, which is credit demand. So it says household wanted to borrow, and they did. The positive white shocks here, this is saying that the cost of private default was priced very low. So the credit market was bullish. And so these guys wanted to borrow, and they could borrow. So then there's a private lending boom. It's not that big, though, in Greece. What's big after that, it's this green stuff. That's the autonomous government spending, which is for some reason the Greek government decides to spend more than what you think based on our simple rule. So that goes all the way to 2007. And then what triggers the reversal is first the sudden stop, and then the sovereign risk. That is, when the government sees the cost of fund going up, it's gonna cut spending. And after that, we get a negative spending shock. That's because after the default, the spread goes down, but the government keeps its spending low because they're in the program. So the model interprets that as a reversal of what they did before. Okay, so the counterfactual then. I think you can guess what's going to happen now. So in this model, everything has shock times multiplier. Multiplier is increasing in leverage. Leverage, of course, here means credit to GDP for the private sector, sovereign debt to GDP for the government. And these are the ratios for emerging market, like 0.4. And Greece is at least twice as high. So we're going to do a simple exercise. Resimulate this series of shocks. These are the log shocks, so they are scale-free. Resimulate that with an economy that has a leverage ratio of your typical emerging market. And what you find is investment, for instance, let's focus on investment. The cumulative drop is about 20% less than it was in the previous model. So we did that for emerging market. Then we do a banking union exercise, that's easy because banking union literally means that this is 0. That's the definition of a banking union. The cost of fund does not depend on the location. So you can just shut down that shock, resimulate, and in terms of magnitude, again, cumulative improvement in investment around 20%. The last one, I can tell you briefly. The last one we did is we shut down the green shocks in the boom, which is we let them follow the normal rule, but without their excessive spending. And then, of course, after that, everything looks better because they have less leverage, less credit, so they have to do less austerity. And again, ballpark estimate, you get about cumulative 20% improvement in investment.